Hi everyone, so we're going to start with the second part of this electronic dice project, which is the counter circuit, or the Johnson counter. So to build that, we need to get the 4017 IC. So if you have a look, it'll look like this. It's got 14 pins on it, or 16 pins. 2, 4, 6, 8, yep, 16 pins on it. And this one definitely has a notch on one end of it. So you should see there's a definite notch on there. Ignore the little circle. We need to look for the notch there. And that means that if you've got the notch on the left, the bottom left is pin 1. Okay, so this is what we call a CMOS chip, integrated or CMOS integrated circuit. So it's a type of technology. There's a couple of different types of technology for making these sorts of chips. And this one has a precaution when you're handling it, in that if you were to give it a shock with static electricity, you could damage the chip. So one of the easiest ways to protect from that, if you're carrying it around, is to just connect all of the pins together on your thumb or finger, like so. There we go. Another way that we can protect it is when we insert it into the breadboard, making sure that we've disconnected the power supply. So don't connect the battery up to, or disconnect the battery clip from the rail before you insert it. And we connect the power supply pins as the first thing that we do. Okay. So using some breadboard wire, or in what I've used is a resistor lead, we're going to connect pin 16, which is the top left pin if you've got the notch on the left. I'm going to connect that to positive with a bit of breadboard wire or resistor lead. And the bottom right hand side pin is pin 8. That is the negative power supply connection for the chip. So we're going to connect that to our 0 volt power supply rail. Okay. So once you've got that in, that's the first thing to do, and that'll protect the circuit a little bit from any static discharge that you might actually accidentally do while just working on breadboard. Okay, so looking at the schematic diagram, you can see that we have a rectangular box that shows all of the pin connections that we are interested in. You'll notice that the power supply pins aren't shown. That's because they're implied that they are connected. This is one of the other reasons why you should always connect these on as the first thing you do, so that you don't forget later on. Okay, so the first one that I'm going to connect is the pin labelled EN, which is the enable pin. And its function is to tell the integrated, or the IC, to either see the clock input or to ignore it. So the clocking input is on pin 14, and it's got that little sort of arrow looking on it, the arrow symbol there. And so the enable pin tells the chip to either look at that or ignore it. And you'll see that it's connected to ground. And so just using a piece of breadboard wire, and in this case I've already cut it to length, I'm going to connect pin 13 to ground. Now I could count all the way around, or I know that the highest pin number is 16, so I can count backwards. So 16, 15, 14, 13. So it's the fourth one from the left on this top side. So connecting that in there like so. And connecting it to the 0 volt rail. It's a little bit fiddly, so I'm going to use my pliers to help me bend the wire. If you're having trouble with breadboard wire, so included in your kit I've given you some breadboard wire, and it's still in the plastic cover. You can cut it to length, and I would suggest about this long, or maybe the length of the width of this breadboard is probably a reasonable length to cut the piece of wire. And you can remove it from the yellow casing. And in order to strip it, I found the easiest way is, oh, well, this bit is already stripped, but I'll demonstrate what I mean, is holding it with a pair of pliers, with the needle nose pliers like that, and using these side cutters. So these are the side cutters. I've got a finger on the inside there, like so, and when I go to squeeze, I can actually control how hard how much pressure I'm putting on in between the cutting edge. So squeezing around the outside there like that, and all I need to do is just enough to weaken the outside plastic. So I don't need to cut through it, I just need to weaken it. So squeeze and then pull out. Okay, and so while squeezing it tight, and if you do it well enough, it should, you might have seen there, it just peels off the outside layer of plastic without damaging the wire. Okay, so you can prepare your breadboard wire like that, and it's probably a good idea to do that before you start building a circuit. Okay, so I have pin 13, which is my enable pin, connected to 0 volts. The other connection I'm going to make, you'll see the pin labelled R on the diagram, or pin 15, that's the reset pin. Now the reset pin tells the chip to make Q0 high, and all of the other outputs, so all the other pins labelled Q, makes them go low. So when I talk about high and low, I'm talking about logic high and logic low. So logic high would basically put 9 volts in this circuit on the output. Logic low would put 0 volts on the output. And because this is a digital circuit, when it's logic high, if I have that connected via a resistor or something, it will push current through that resistor. These circuits are able to provide enough current to light an LED, but only just. Okay, so we're going to connect the reset pin to Q6, which is pin 5. Okay, so using another piece of breadboard wire that I prepared earlier. So pin 15, which is the one right next to the end one there, to pin 5. So 1, 2, 3, 4, 5 goes all along to the end like that. And just pushing it down so it's out of the way. So you can see here now I've got pin 15 connected to pin 5. And what this will do is that, so pin 5, which is Q6, that's going to be the 7th number in the list. So we would go 1, 2, 3, 4, 5, 6, and then when it would count to 7, it tells it pretty much straight away to go all the way back to 1 again. And so this is going to make our counter count from 1 to 6 and then back to 1 again. Now finally, the next connection that we should make is the connection between our astable circuit that we made before and our clock circuit, or counting circuit. All we need to do there is connect this pin 3 of the astable, of the 555 circuit, onto pin 14, which is the clocking input pin on this circuit. So again, using a piece of wire that I prepared earlier, connect that onto pin 3, that goes on to pin 14, like so. So there's our connection between the two. Now this one is a little bit hard to test. We still can. So if I light this up now, you see that it's flashing. Using your multimeter, set it to measure volts, set on 20 volts. So connecting the black probe to the 0 volt rail, and let's just put it on pin 3, which is the first one. So I'll put it on pin 10 actually. Pin 10 is also 8, 9, 10. Is that one? You can see every so often we see a voltage being recorded on there. Now it doesn't do a very good job because this meter takes a bit of time to do a proper measurement, and the voltage is only high on this for a very short amount of time. So basically the time it takes for it to pulse one of those, and it's only doing once every 6 pulses. But we can see that that's actually at least doing something. If it wasn't changing at all, I would be suspicious. Okay, so now we've got our counter circuit working. The next part of the circuit will be the logic.